This is section 4.6, part B. Another application of rational expressions or rational functions is solving variation problems. We'll look at two types of variation. We'll look at direct variation, and we'll also look at inverse variation. If you have a problem where something varies directly as something else, like y varies directly as x, or perhaps it might say y is proportional to x, the equation that governs that is y equals some constant k times x. K is usually called the variation or proportionality constant. If we say that y varies inversely as x, or is inversely proportional to x, then instead of y being k times x, we have y as k divided by x. In most cases, it's necessary to do two steps to solve a variation problem. You'll have some given information that allows you to actually solve for the variation constant. So essentially step one here is find k. And then step two, substitute in to actually answer the question that you were asked. So let's take a look at a couple of examples. In example 1, y varies directly as x. As soon as I see that, I'm going to write my variation equation. The direct variation equation, y equals k times x. All right, next they tell me that y equals 18 when x equals 3. This is the information that I'm going to use to find k. I'll just substitute it in. Y is 18 when x is 3. And dividing by the 3 tells me that k is equal to 6. Finally, I'd like to find y when x equals 5. So I now know that my equation is y equals 6x. And they've literally told me that x is 5. So substituting that in gives me y equals 30. All right, let's try another one. In number 2, we're told that y varies directly as x squared. So my variation equation is y equals, instead of just k times x, this time it will be k times x squared. But again, it's direct variation, so it's k multiplied by whatever's there, in this case, x squared. Once again, we're given the information that y is 18 when x is 3, so I'm going to plug that in. And let's see, 3 squared would be 9, so that's actually 9k. And then dividing both sides by 9 gives me k equals 2. So I now know y equals 2x squared. To finish, I need to find y when x equals 5. So I'll just plug in x equals 5. And 2 times 25 is going to give me 50. All right, let's try a couple more. In number 3, we're told that y varies directly as the cube of x. So again, it's direct variation. Y equals k multiplied by something. But this time it's multiplied by x cubed. Getting bored with these inputs, but we're going to use them one more time. Y is 18 when x is 3. So 18 would equal 27k. And if I divide by the 27, 18/27 reduces to 2/3. So now I know that y equals 2/3 x cubed. And finally, to answer my question, find y when x equals 5. I'll plug in my 5 for x. Let's see, that would be 2/3 times 125. And that's just going to be 250 over 3. I don't think, other than going to an approximate decimal, I can get any closer than that. All right, so there are several direct variation examples. But what I really want to point out to you here is the importance of reading. When you have that direct variation, y is equal to a constant times something, make sure you read really carefully to see what you're multiplying by. It's not always just an x here. The same thing goes for inverse variation. Here I have d varies inversely as t. So d varies inversely, so that's going to be k divided by something this time. And specifically, it's varying inversely as t. All right, next information I'm given is going to help me find k. So d is 4 when, d is 5 when t is equal to 4. So 5 for d, 4 for t. And now you're starting to see a little bit of a rational equation. We've got a fraction in there, not a real difficult one, but it's there. If I just multiply both sides by 4, I'll get 20 is equal to k. So now I know that d is equal to 20 divided by t. And that means I can answer this last question, find t when d is equal to 9. So 9 in for d. And once again, I've got a little rational equation. I'm going to multiply both sides by the LCD, which is t. And that allows me to divide out the t's over there on the right. So I have 9t equals 20. And t is 20 divided by 9. All right, let's try another inverse one. This time, d varies inversely. Oops, let me get that set up so it doesn't fall. This time, d varies inversely as t plus 3. So d equals inversely, so k divided by t plus 3. We once again have d being 5 when t is 4. So we'll plug those values in. That says 5 is equal to k divided by 7. And I'll just clear the fractions multiplying both sides by 7 to find that 35 is equal to k. So I now know that d equals, k is 35 over t plus 3. I'd like to find t when d equals 9. So I'll put 9 in for d, and we'll solve for t. Notice again we've got a rational equation. I'm going to clear the fractions by multiplying both sides by the common denominator, which is the only denominator, t plus 3. Just make sure that you do it on both sides. And on the left, when I distribute the 9, I get 9t plus 27. On the right, I can reduce, dividing out the t plus 3's, and I get 35. Subtracting 27, 9t is equal to 8, and so t this time is 8/9. All right, all of these problems have been set up in exactly the same way. They've just flat out given you the information that you need. In the next video, we'll look at a couple of application problems where you have to dig a little bit harder for the information, but we'll still have these variation situations.